we'll get to the postulates here. So at the beginning, what a postulate is. A postulate, or it can also be called an axiom. But we had postulates in our properties packet, like the segment addition postulates. So a postulate is a statement that is accepted as true. So it's just accepted as a fact. It's not proven. It's just accepted, like, okay, that is something that's true. Postulates describe fundamental relationships in geometry. So these postulates that we're going to go through are dealing with points, lines, and planes. Directly ties into what we talked about in regards to points, lines, and planes in chapter 1. And they're just things accepted as true in geometry. So basic ideas about points, lines, and planes are accepted without proof. If something is a theorem, for example, because we had theorems in there, theorems are things that are proven. So postulates are accepted without proof. And as it says here, they are the building blocks of geometry. So going through just to quickly discuss these postulates regarding points, lines, and planes. And then we'll use them in different ways on the back of the sheet. So postulate 2.1, again, you don't have to memorize the number with the postulate, but make sure you understand the idea behind it. So this says that through any 2 points, there's exactly one line. Okay, hopefully that makes sense. We talked about that in chapter 1, that to have a line, you need 2 points. We can use 2 points to name a line. So through any 2 points, there's exactly one line, is postulate 2.1. Postulate 2.2, through any 3 non-collinear points, there's exactly one plane. What does non-collinear mean? Not on the same line. And we talked about that to name a plane, you could use 3 non-collinear points. So any 3 non-collinear points, there's exactly one plane through those points. In postulate 2.3, a line contains at least 2 points. So that's kind of tying into 2.1 up there. So a line has to have at least 2 points. You can't have a line with just, like, you can't have 1 point and have a line. You have to have at least 2 to connect them. Think of graphing a line on a coordinate plane. You have to plot at least 2 points in order to draw the line. If you just draw 1 point, you don't know which way the line is going. So line contains at least 2 points. And then 2.4, a plane contains at least 3 non-collinear points. That ties into 2.2. So a plane has to have at least 3 non-collinear points. 2.5, if 2 points lie in a plane, then the entire line containing those points lies in that plane. So if 2 points are in a plane, and we know through any 2 points there is a line, then the entire line is also in that plane, is what that is saying. So I should highlight this part. Okay, and then the last 2 is talking about intersections. So if 2 lines intersect, their intersection is exactly 1 point. So 2 lines intersect at a point. And 2.7 is talking about planes intersecting. If 2 planes intersect, their intersection is a line. So if 2 planes intersect, they create a line. So here line W would be the intersection of the planes F and D. So some of the questions on the back, we are going to be kind of flipping to name the postulate. But again, you don't have to, thinking ahead to your quiz, name the postulate, like the number of the postulate with a question. So this is just getting us used to the postulates when we have them available to us. So it says state the postulate that shows each statement is true. So it does give a diagram. Some of these I think you could probably read through and not necessarily need to see the picture to name the postulate based off what the postulate says. So 1 says planes P and Q intersect in line R. So you could look at this, plane Q is this front face, plane P is this side face, and then we can see line R is where they intersect. So which numbered postulate says that planes intersect in a line, okay? 2.7, okay, that's all these are asking you to do. And then number 2 says lines R and N intersect at point D. So you can see that from the picture, line R, line N are intersecting at point D. So which postulate would confirm that? Okay. 2.6. So that's basically saying two lines intersect at a point, which is postulate 2.6. Then it says line N contains points C, D, and E. So if you look at line N, you can see those 3 points on that line. But what postulate do you think that would be? Line N contains points C, D, and E. Any ideas, Kai? It is 2.3. So if you look at 2.3, it says that a line contains at least 2 points. So that's 2 or more. So if it's saying a line contains 3 points, it's meeting that postulate. It has at least 2 points on it. Then number 4, plane P contains the points A, F, and D. So if you look at plane P, which again is this left side face here, A, F, and P are on that plane. Katie? 2.4, yes. 2.4 says a plane contains at least 3 non-collinear points. It did name 3 points. If you look, A and P are on the same line, but F is not. So they are all 3 non-collinear. And then 5, line N lies in plane Q. So which postulate do you think confirms that line N? We see it on the edge of plane Q, but that is considered in plane Q. Which postulate do you think would say or confirm that line N lies in plane Q? 2.5. If 2 points lie in a plane, the entire line containing those points lies in that plane. So plane Q does contain these 3 points actually, D, C, and E, and line N therefore would be in that plane. And then line R is the only line through points A and D. So you can see from the picture that that's true, but what postulate would tell you that line R is the only line through points A and D? Kylie? 2.1. So 2.1 says through any 2 points, that would be your points A and D, there's exactly 1 line. So that would be line R, it's the only one. Okay, so that's just, again, naming the postulates you won't have to do on your quiz, but understanding them, you will have to understand the reasoning behind them. So that's just kind of forcing you to look at the postulates to answer those. 4, 7, and 8, it says up above, so it says AC is, anyone remember what this symbol means? Parallel, is parallel to? So AC in our figure here, AC is parallel to DE. So it says state the postulate that can be used to show each statement is true. So look at these together as well, knowing that AC and DE are parallel. So 7 says exactly 1 plane contains points F, B, and E. Exactly 1 plane contains points F, B, and E. Which postulate do you think that would be? Okay. 2.4 is close. It's not 2.4 though. Melcher? It's not 2.3. 2.3 is about a line. Not 2.5, 2.2. I heard somebody say. So 2.2, because it's saying through any three non-collinear points, there's exactly one plane. And this is just kind of said in reverse that exactly one plane contains these 3 points which are non-collinear. If you look at the picture, F, B, and E are not on the same line. So even though it's not the plane Q that we see, because F is not on that plane, but there would be exactly one plane through them. So that is 2.2. And then 8 says line BE, which again is not drawn on the figure. Line BE lies in plane Q. Which postulate do you think would confirm that? Line BE lies in plane Q. Any ideas? Emma? That would be 2.5. Because 2.5 says if 2 points lie in a plane, the line containing those points is in that plane. So B and E both lie in plane Q. Therefore, if there was a line drawn through them, it would also be in plane Q. That's 2.5. Okay, now getting into some always, sometimes, never questions. These I want to discuss together as well. So, and here if they are, well, depending on what it is, I might, not that it asks you to, but I might write down the reasoning as to why. That'd be good to have in your notes too, just because these are understanding the relationships that we're talking about with points, lines, and planes. So 9 says a line contains exactly one point. Is that always, sometimes, or never true? That a line contains exactly one point. I heard sometimes. I heard never. Okay, I heard a lot of nevers. Why are you saying never? Yes, a line has to have at least 2 points. So that's, we're not naming the postulate, but postulate 2.3 says a line contains at least 2. So this would never be true. I'm just going to put an N, and then in parentheses, I'm going to say a line has at least 2 points. So look for phrases or words like the fact that they're saying exactly one. If you look for things like that, that can kind of clue you in to it maybe not being always true, although sometimes it could be. So just kind of pick out those phrases. These are kind of like true-false questions. They're just tough. You have to really pay attention to the wording. So 10 says non-collinear points R, S, and T are contained in exactly one plane. I heard always, I heard sometimes. Anybody have a reason as to why you're saying always or sometimes? Faith, I saw your hand first.
I just said it was sometimes because it doesn't specify if there are other points on the plane. They don't have to be put.
Okay. And then Kai, were you going to say, did you say sometimes also, or did you say always? No. Why'd you say always? You're looking at 2.2, which says through any 3 non-collinear points, there's exactly one plane. And this says non-collinear points R, S, and T, which would be 3 non-collinear points, are contained in exactly one plane. So I would say that's always true. Okay, so even though there's like RS and a different point. There could be, other than T, there could be other planes that RS and T are a part of separately, but those three non-collinear points, exactly one plane contains those three. So this is always, I'll just put in parentheses, I'll put postulate 2.2, because that is basically what postulate 2.2 is saying. Okay, 11, any two lines, L and M, intersect. So any two lines, L and M, intersect. Would you say that's always, sometimes, or never true? Sometimes? Why sometimes? They could be parallel. Lines could intersect. Not all lines intersect. If they're parallel, they don't intersect. So I would say this is sometimes. And then as a reason, could be parallel. So if you say sometimes, you have to have a reason when it would not be true. You have to have a reason when it would be true and when it would not. We know lines could intersect. They would not intersect if they're parallel. Okay, 12, if points G and H are contained in plane M, then segment GH is perpendicular to plane M. That is a lot of words. But I heard a never, I heard a sometimes. Any reasons to back those up? Quinn? Okay, so if G and H are both in plane M, and then it's saying segment GH is perpendicular to plane M, think even like perpendicular lines. I'll try to draw this. So you have a plane, just kind of picture this as like a flat piece of paper or something. And then if a line is perpendicular to that plane, so it intersects to go through, and where that intersection occurs, there'd be a 90-degree angle. So to have segment or line GH, so this could be point G or H, but that means the other point would not actually be on or in the plane. So it would be never. So for this to be accurate, one of those 2 points cannot be in the plane, which makes this never true. This is never, and then I'll just kind of put here for this statement, G or H would not be in plane M for that to be perpendicular, which contradicts the beginning statement that they are both in plane M. Okay, two others. So 13, planes R and S intersect in point T. Okay? Never. Why? So that is correct. It is never true. Planes intersect in a line. In a line, not a point. And the last one, if points A, B, and C are non-collinear, then segments AB, BC, and CA are contained in exactly one plane. I heard an always. I heard a couple always. Reason? It is always. What's the reason why, though?
Because there's points in the plane, they could be connected by lines.
Okay, yes, this is actually, it's connecting two of the postulates. So one postulate says if points A, B, and C are non-collinear, they are contained in exactly one plane. That's postulate 2.2. Then postulate 2.5, I know talks about lines, but segments are parts of lines. So then 2.5 says if 2 points are in a plane, the line containing those points is also in that plane. So if these 3 points are in the plane, their segments connecting them would be in the plane. So this is a combination. I'll put postulates 2.2 and 2.5. So kind of the combination of those is what's telling us that's always true. Okay, any questions there? Okay, I'm actually, so 15 through 20 are then similar to 1 through 6 above where you're looking at the postulates, naming them. What I'd like to do though is pass out the assignment.